Hello students, welcome to E-pg Pathshala. I am Dr. Himanshu Arora from Department of Anthropology, University of Delhi. Today we are going to study a module titled Concept of Biological Age and its Relevance in Human Studies from the paper Biosocial Gerontology. First of all, let's start with the learning objectives of the module. After going through this module, you will be able to get familiarized with the concept of biological age and chronological age. You will be able to understand the factors which influence biological age. You will realize the need to know about one's biological age, and you will understand the different ways of assessing biological age. Now, we'll give you a glimpse of the topic through brief introduction. Process of growth starting from conception, continuing till the child grows into a fully mature being, distinguishes him or her from an adult. Growth is characterized by net increase in size or mass of tissues, and development signifies maturation of organs and of functions. Growth and development are influenced by genetic, functional, environmental, nutritional, metabolic, social, emotional, and cultural factors to a great extent. The process can be assessed by taking into account the increase in height and weight as an entity when studying longitudinally. Pace of these changes taking place varies from person to person. In some individuals, the development changes might appear earlier, while among others, same might take place at a slow rate. One aspect of growing children that gets noticeable by all of us at school is the fact that in the same class of children, some look very young while some look mature than the others, with one group in between. These observations makes one wonder if there is some other way to assess biological maturation. Even in adulthood, people of the same chronological age look younger or older than their peers. Here it is important to introduce the fact that human body has two types of age, chronological age and biological age. Chronological age, it is the one we are familiar with as the number of years denoted by Earth's revolutions around the Sun. It is the current age in years calculated from the birth date. Chronological age is the actual number of years a person has lived in years, months, days, or a combination of all of these. For example, 15 years, 3 months, and 12 days. Biological age, on the other hand, represents the biological status of maturity, referring to how old a person seems to be. It is an individual's development based on certain biomarkers, a recordable molecular or cellular event. Biological age, also called physiological age, determines the extent of body functioning relative to actual calendar age. For example, one may have a calendar or chronological age of 65, but because of healthy and active lifestyle, avoiding longevity threats like consumption of tobacco or subjection to obesity, that person is physiologically more similar to someone with a chronological age of 55. In that case, his or her biological age would therefore be 55. So, the biological age is a measure of how time and lifestyle have affected the organs and cells compared to other people of the same chronological age. Experts considers telomeres while calculating the age difference between the chronological and biological age. Telomeres prevent chromosomal ends from deteriorating or fusing with a neighboring chromosome, affecting the tempo of aging of cells. It implies that greater the chronological age, the shorter the total length of telomeres will be. However, maintaining a healthy lifestyle inclusive of a healthy diet and regular exercise may also maintain telomere length. Now we will discuss factors affecting biological age. There exist several factors which can determine or influence the biological age of an individual, but none of these are definitive or accurate. Rather, that would give years on an average life expectancy. Lifestyle. Healthy living habits have a significant impact on longevity and extended biological age. These majorly include exercise or physical activeness, eating or dietary habits, stress levels, alcohol or tobacco consumption, level of education, amount of sleep, sexual or romantic relationships, enough of physical activity, dietary pattern constituting more of nutrient rich content and less of fatty entities, less or no stress, and keeping it away from drinking and smoking tend to influence longevity in positive terms. Decreased biological age has been found associated with lower educational background and lesser hours of sleep. Heredity. Genetic predisposition or vulnerabilities are other major factors responsible for influencing biological age. Heredity or gene pool contributes to increased biological age that has nothing to do with lifestyle habits. Just as the way specific diseases run in families, longevity also does. If a person has family members who have lived longer than 96 years, chances are that the person would also lead a longer life even if his or her lifestyle patterns are less than healthy. Habit or geographical nativity. Another important factor influencing biological age is the place where you live. There lies no secret in the fact that environment and culture one lives is indirectly linked to the person's healthy living. Now, we will study why biological age matters. Sometimes, the onset of health problems can be late in terms of showing their symptoms. The human body is designed in such a way that it can undergo healing itself and make allowances for deficiencies for a long while before it is overcome and gives way to diseases. At this point of time, where the symptoms of diseases begin to interfere with our daily lives, we are not left with any other choice than to visit a doctor. But what if we could somehow detect such health challenges long before then and get a chance to correct them? That would truly be the best option. Everyone ages, but the health problems that we must deal with as we age make a remarkable difference in our biological age and quality of life. Assessing biological age helps to find out in moments what a person's biological age is and how this age is changing. To some, this might mean they are aging too rapidly. For others, good habits may reveal that their biological age is progressing slowly, making them healthier and more youthful. It is never too late to make changes in life either. No matter what the results are, being able to track one's biological age will help finding out whether one is heading in the right direction for health or if the person needs to turn around and ask for help or suggestions. There resides a direct link between vitality and behavioral changes. Healthy living is equated with slow aging, whereas unhealthy lifestyle choices are equivalent to rapid aging. Knowing one's biological age is same as knowing how healthy and strong a person is and whether he or she is at risk for life-threatening diseases such as high blood pressure or diabetes. What if one's biological age is higher than the chronological age? If it acts as an indicator that it is a crucial time to make positive changes which can make positive difference in the individual's life. The aim here is to put a focus on those habits that lessen age expectancy, changing them into healthy habits that can add some more years to the life. This is possible by addressing some of the following issues. Quit smoking and consumption of alcohol, add more fruits and vegetables, lean meats and water to your daily diet, practice good sleep hygiene by turning off screens and relaxing an hour before you go for the night sleep, get more exercise done by starting a fitness program, learn techniques for the stress reduction and management, such as meditation or deep breathing. Following all or even some of these basic suggestions, one is sure to be healthier than most adults and thus be younger than the chronological age. And exercise is just one area of simple lifestyle changes one can make to go younger and healthier. Aging process is something one can have an influence on because lifestyle related factors play a very crucial part in determining the health and biological age of a person. In order to slow down the aging clock, one needs to find out where it's currently set by determining the biological age versus the chronological age. By getting an accurate assessment of where problems lie, an individual will gain the motivation to work to improve upon these areas. People are living longer these days and are concerned about being able to afford health care as they live longer. They are looking for ways to lower health care costs and take hold of personal responsibility for their health. That is why it is important to know your biological age. Knowing where the problems exist, one can initiate the lifestyle modifications necessary to improve health and increase vitality. Determining biological age and matching it with chronological age is also very important among growing children and adolescents in order to prevent atrocities, injustice against the minor children, for example, asylum detention, matters related to court of law, to name a few. Biological age can be determined through anthropological assessment. Weight and height are physical manifestations of growth and development. They are utilized the most in diagnostic procedures and in assessment of growth and development. Body mass is probably the best criteria of nutrition and growth because it sums up all increments in size. By comparing the height and weight of a child of a given age with the standard height weight values of the same age group, one can assess the relative growth rate as well as the factors responsible. By comparing the sexual maturity indices like breast development stages, penile development stages, appearance of facial and body hair, one can fairly assess and match the biological and chronological age of growing children. Skeletal assessment. The skeletal maturity of the individual is known as bone age. Bone age is an appropriate indicator of physiological development and is distinct from the chronological age. Appearance and fusion of different skeletal centers of ossification follows a fairly definite pattern and time schedule from birth to maturity. Raw endogenographic study of these skeletal maturational processes provides valuable criteria of a children's level of osseous maturation. This helps in assessing whether the child is advanced in skeletal maturity as compared to his or her peers of the same chronological age or is lagging behind. Dental assessment. The development and eruption of teeth are part of child's total development. Tooth eruption and development is a useful measure of maturity as it represents a series of recognizable events which take place in the same sequence from birth to maturity. Estimation of dental age is based upon the pace of development and calcification of tooth buds along with their progressive sequence of eruption in the oral cavity. Tooth calcification provides a valuable indicator of dental age, serving as an index of maturation of child. Tooth calcification being a continuous development process should be considered a better measure of physiological maturity than dental emergence. Hence, several methods have been developed in order to assess dental age according to the degree of calcification observed on permanent teeth. Early prevention and interception of dentofacial deformities is dependent upon an accurate interpretation of the inherent facioskeletal pattern and overall growth and Development series. Physical growth and development manifestations provide useful basis for orthodontic diagnostic evaluation. Physical characteristics comprising of weight, height, skeletal maturation, and dental development are subjected to biometric tests and compared with standards based upon large groups of healthy subjects in order to evaluate the growth and maturational status of people. Differences between dental, skeletal, and chronological age is of greater interest in ascertaining an advancement or delay compared to standard growth. Besides bone age, dental age is also used to study somatic maturity. Eruption and calcification of dental tissues is used to determine dental age. Tooth calcification is superior to tooth emergence because emergence of a tooth a fleeting event and its precise time is difficult to determine, whereas calcification is a continuous process that can be assessed by permanent records such as X-ray films. Now we will describe concept of age in sports and training. Development and maturity appear at different chronological ages. Chronological age of a person may be lesser than his or her biological age, making him or her an early maturer, while for late maturers, biological age is generally lower than chronological age. In sports, biological age refers to the biological status or maturity of the athlete depending on whether he or she is a pre-adolescent, adolescent, or an adult. Technical training age refers to an athlete's technical ability in a given task, strength training, or sport specific. In most cases, particularly in team sports, athletes are grouped purely on their chronological age. The term age is described as typical or ideal group training category in which athletes are separated. For example, team sport athletes are typically separated by chronological age and in some circumstances based upon technical training age. However, athletes are rarely separated by biological age. Over past few decades, sports science and strength and conditioning have become increasingly popular professions that has led to many practical and scientific progressions, one of which is the understanding of individuality, which infers that no two athletes are the same and that they can vary by gender, age, ability, physical and psychological maturity, anthropometrics, and training necessities. For example, this implies that training programs must be individualized in order to maximize the athleticism of each athlete and protect them from any personal predisposing injuries. For this reason, exercise specialists have begun to categorize their athletes not only on the basis of their chronological age but also by their biological and technical training age. Chronological age in sports and training. This form of categorization is most commonly adopted when working with athletes. However, the primary issue in doing so is the large variance between individual abilities that is often exaggerated in young athletes due to differences in both their biological and psychological maturity. For example, in an under 17 boys rugby team, some players may have almost reached full physical maturity while others may have yet to undergo their peak height velocity. This can result into larger variance in physical and psychological maturity, limiting the physical potential of the athletes by potentially increasing risk of injury, reducing intergroup competition, and generating distractions, failing to cater training necessities for each individual. Biological age in sports and training. In comparison to chronological age, the classification of biological age is far more complex as it is often determined differentially depending on whether the exercise professional is calculating the biological age or the status of a pre-adolescent, adolescent or adult. Biological status of adults can be accurately estimated only with medical expertise. Extensive assessments On the other hand, biological age or maturity offset of youths can be determined using non-invasive anthropometric measures that require minimal equipments. Analyzing biological status of a young athlete is typically done by calculating the maturity offset of the individual predicted years from peak height velocity by using several anthropometric measures using age, standing height, sitting height, and leg length most of the times. By objectively measuring maturity offsets of a group of young athletes, training groups can be restricted according to their biological status. This enables young athletes to be categorized based upon their physical and psychological status and training goals. Availability is often the primary issue with categorizing athletes based upon their biological age, especially when working with young team-based athletes who have set sport-specific technical training timings based on their chronological age. Technical training age, most often referred to as training age, is a relatively straightforward classification. It purely refers to the total training time or experience the athlete has in that aspect of physical training, be it strength training, Olympic weightlifting, plyometrics, speed, or agility. It is vital that the strength and conditioning professional considers all the elements required for carrying out training in a particular sport activity and performing it, and should test the athlete's competencies before writing and administering any program. Another major limitation of training age as a form of categorization is that quantity of experience by no means suggests quality. Again, the strength and conditioning coach must consider these factors and determine the athlete's movement quality prior to administering any form of training plan. Through rearranging the athlete's training schedules to suit their biological and training age can be difficult in team sport environments, but it may also be a worthwhile investment if it is benefiting the physical well-being and development of the athletes. Understanding the difference and importance of chronological, biological, and technical training age is instrumental for the provision of strength and conditioning, particularly when it is the coach's responsibility to maximize physical potential of each athlete. Now, we will summarize what we have studied till now. Pace of growth and development varies from person to person. In some individuals, the development changes might appear earlier, while among others, the same might take place at a slower rate. Human body has two types of age, chronological age and biological age. Chronological age is the current age in years calculated from birth rate. Biological age, also called physiological age, determines the extent of body functioning relative to actual calendar age. Development and maturity appears at different chronological ages. Chronological age of a person may be lower than his or her biological age, making him or her an early maturer, while for late maturers, biological age is generally lower than chronological age. Aging process is something one can have an influence on because lifestyle related factors play a very crucial part in determining the health and biological age of a person. In order to slow down the aging clock, one needs to find out where it's currently set by determining the biological age versus the chronological age. By getting an accurate assessment of where problems lie, an individual will gain the motivation to work to improve upon these areas. There resides a direct link between vitality and behavioral changes. Healthy living is equated with slow aging, whereas unhealthy lifestyle choices are equivalent to rapid aging. Knowing one's biological age is same as knowing how healthy and strong a person is and whether he or she is at a risk of for life-threatening diseases. Biological age can be assessed using anthropometry, skeletal and dental evaluation. Physical characteristic comprising of weight, height, sexual maturation, skeletal maturation and dental development are subjected to biometric tests and compared with standards based upon large groups of healthy subjects in order to evaluate the growth and maturational status of patients. Differences between dental, skeletal and chronological age is of greater interest in ascertaining an advancement or delay compared to standard growth. Besides bone age, dental age is also used to study somatic maturity. Eruption and calcification of dental tissue is used to determine dental age. Tooth calcification is superior to tooth emergence because emergence of a tooth is a fleeting event and its precise time is difficult to determine, whereas calcification is a continuous process. Thank you.